Well, hello everyone. I am Professor Marcos Santos, and today I will talk about the modeling process. This idea it's so important in operational research context because all the time we work with many problematic situations and we need to become a problematic situation in a set of equations that can support the decision. So let's see a short presentation that I made. Here you are. Like I said, the modeling process. So let's talk about a little bit the modeling process. So here you can see a short resume about my academic life, my professional life. I have been working in the Brazilian Navy for 28 years. And in the Navy, I could study operational research, and I have been studying operational research for many years to solve specific problems inside the Brazilian Navy. So the Brazilian Navy says, oh, I have a problem, I have a complex problem. So my team understand the problem and we can build a decision model, I can say. So, and I work in the Navy and I work at the Military Institute of Engineers. I teach advanced mathematics. And I develop many software that can solve complex problems, complex models. So we develop the mathematical models, and we can transform these analytic models in softwares that you can easily find the results. That's my research at Military Institute of Engineers. So, like I said many times here in Operational Research House, I like so much Hopper methodology because we have a methodology step by step from the understand the problem to solve the problem. And the first step is define the system we are dealing with. In other words, I need to understand the problem to solve it, because if I can understand the problem, I can find the solution. Looks very very obviously makes sense. So I think, I'm sure that this first stage, I'm sure it is the most important stage of the Hopper methodology. I need to understand the problem, to defining measure of effectiveness, construct the model, get a database, optimize our solution, and report, explain, and so on. So I need to understand the problem. And the first stage, I think, is the most important stage. So after understand the stage, the next step is defining a measure of effectiveness and construct a model. So let's see next picture. So look at this picture. First, we are here. We are in real world, and we have a real world problem. So I need to transform a problematic situation in the real world. I need to transform in symbols. I need getting in mathematical world. So I can transform this real world problem in a mathematical problem. But to do that, necessarily, I need to make some assumptions, because a model, it isn't the reality. I need to make assumptions. I need I can say that a model is I need to simplify the reality, because the world is very complex. It's very how can I say, is very complex, is very I don't know the exact word, but for me, it's so difficult to understand the real world. So I need to make many assumptions to construct a mathematical problem. So, and I can formulate the equations, and I can use many different models of the operational research. I can use Monte Carlo simulation. I can use discrete simulation, statistics, linear programming, Q theory, multi-criteria decision analysis, whatever you want. So after that, after the formulation, the equations, I can solve this equation. So these equations give me a result. But now, with the result, I need to interpret this result. I need to interpret these solutions and compare with my data. So with the solution in my hand, I need to come back. I need to come back to the real world. I need to come back to real world. And I need to think, oh my goodness, this number that I found, it makes sense to solve this problem, because a number is just a number. I need to think with my knowledge, with my perception, with my intelligence. I need to think if the number that I found with the model makes sense in this specific problem. So that's why I need to return to real world. So look, we have two movements. The first movement, I travel from real world to mathematical world. And inside the mathematical world, I can construct my model. So after I found my results, I need to come back to the real world, and I need to think if this number makes sense to me and makes sense to the problematic situation, you know? So I often say with my students, with my research group, I show them this picture and play with them. Look, we have two men. There are two men, and if you look the data, we will see the same data. We have the first man here and the second man here. So, like I always tell to my students, master degree and doctorate degree here in Military Institute of Engineers, if you don't care, you can say we are studying, we are analyzing the same man, because the first is male and the second is male. So the first was born in 1948, the second was born in 1948. Here, the first raised in UK, the second too. The first was married twice, and the second too. So the first lives in a castle, and the second too. And first is healthy and famous, and the second too. So we can have the following conclusion. We are talking about the same man, the same guy. But obviously we are wrong. But if you analyze only the data, we have 1, 2, 3, 4, 6 data. We have a wrong conclusion. The name, the data show me maybe the set of data. We have a set here. Oh my goodness, my pen doesn't work. Okay, no problem. So we have two data sets. And if I analyze these two data sets, I can have the wrong conclusion that I have the same guy, and I'm completely wrong. So that's why I always tell to my students that a number is just a number. We need to analyze the number inside its context. Only the number isolated, it can't tell me anything if I analyze only just the number. And like I said many times here, I coordinate the activities in the operational research house. This is my community here in Brazil. And in this community, in this YouTube channel, we have more than 400 classes with many methods, many approaches, many methodologies, many equations, softwares in Python, or whatever you want. And sometimes I teach a method step by step, like simplex method, like Cusco algorithm, like AHP method, and many others. I've told many different methods in operational research house, and I often invite many other professors to teach another subjects like game theory, constraint theory, fuzzy logic, and many other methods. So if you are a professor, operational research professor, or if you are a student, maybe it's no problem. If you like operational research, if you love operational research, and if you want to share your knowledge with us, you can contact me, and we can schedule a meeting, and you can explain, you can show your research, you can talk about your model, you can talk about your research, whatever you want. You can talk about your software. Our channel, our community is a democratic environment that everybody can speak, everybody can have ideas, everybody can talk your models, you know. So I think very important to share knowledge with our community, with the world, I can say. So if you are interested in share with us your time, your knowledge, your research, you can share with us your research. You are welcome here in our YouTube channel. You can contact me. I am on LinkedIn. I coordinate this YouTube channel, and the next screen you will see my contacts. So thanks a lot for your attention. These are my contacts, my phone number. You can send me a message by WhatsApp or whatever you want. My email here in Military Institute of Engineers. And if you scan with your smartphone, if you scan this QR code, you can connect me on LinkedIn. So that's it. I think this concept, this idea about the modeling process, it's so important for everyone that wish to become operational research, because we work with this process all the time. I have a problem, like I said, I have a problem, and I need to transform this problem in a set of equations. So I need to travel to real world, to symbolic world, mathematical world. And inside the mathematical world, I will construct the equations, I will calculate the solution, and then with the solution in my hand, I need to come back. I need to come back to real world. And I need to think, oh my goodness, this number that I have in my hand, it makes sense to solve this problem. So, like I said, a number is just a number. So that's it. I really wish that you enjoy this video, and you can recommend our YouTube channel to other friends, other researchers, and whatever. And you can, like I said, if you have a model, if you have a research, if you have interesting approach, you can share with us. So see you next time.